Okay, now we're going to be talking about Lewis dot, which is a visual representation of valence electrons. And we're going to be doing it with a color coding of the S and P blocks so we can see how they build. So here's a really important item with Lewis dot. The structure goes right, left, up, down. So when you're putting dots in, it goes right, left, up, down. You don't put them sideways like a dot and a dot because that means there's bonding potential. And two dots together means that there's no bonding potential at that place. Electrons are already in pairs because electrons do want to be in pairs. They get very happy when they can share something together. When two are together, there cannot be bonding. So let's start looking at the Lewis dot. And the really cool thing about Lewis dot and valence electrons is that if you do it for the very top of the column and over here, it's the same structure all the way down. So if you get the first few in, it's the same structure all the way down, which is very handy. So the first thing you're going to do is you're going to put in your atomic symbol. So the first one up here is hydrogen. It's in the S1 block. And remember, we start to the right. So we put in one dot to the right to represent one valence electrons. Now, helium is really funny. Helium's a noble gas. It doesn't want any more. Its electron shells are already filled at S2. It can't have any more. So helium is the one that has two dots to the right because it says, I don't want to bond anymore. I'm already happy. If we go to lithium, again, we're in this first S block, S1. We can write the atomic symbol for lithium like that. And remember, you do one dot to the right to show one valence electron. When we're doing S2, like for beryllium, so Be, it's S2. It's two valence electrons, which means we have to represent two valence electrons. And it goes one to the right and one to the left. Now, we're going to remember that everything in the P block over here has two in the S block, this S2. So a nice thing to remember is that you can go ahead and know that right and left are always going to be pink or whatever color you're using for the S block, because P blocks cannot fill without two from the S blocks filling. So if we're going to be looking at boron, which is the first one here, it has three valence electrons. Of this three valence electrons, two are coming from the S block, 1, 2, and then one is coming from the P block, 3, and we're going to put that third on top. The next one is carbon. Carbon has 4 valence electrons. We're going to put a C here. Of those 4 valence electrons, we're going to go right, left, up, down, remember. 2 are coming from the P block, so 2 are coming from the S block, so 1, 2, and then 2 are also coming from the P block, up, down. So you can represent where all those valence electrons are coming from. For nitrogen, this is 5 valence electrons. You can put an N here because you have to make sure that you are using a proper atomic symbols for the elements, and also remember your caps are important. For this nitrogen, it has 5 valence electrons. 2 are coming from the S block, so right, left is 2, and then 3 are coming from the P block. So now you're going to go up, down, so right, left, up, down, and we have to put the fifth one in, so we go to right again. So you're representing this 2 here means no more bonding. It's filled. It has bonding potential of 3, but it has 2 from the S block, 3 from the P block to represent 5 valence electrons. For oxygen, which is 6 valence electrons, remember, as always, 2 are coming from our S block, so 1, 2, and then 4 are coming from our P block. So you have the up, down, and then you go right, left again, because remember, it's right, left, up, down, right, left, up, down. So you can see here of our 6 valence electrons, 2 are from the S block, and then 4 are from the P block, so it would be S2, P4. And you can see that here, S2, P4. For fluorine, Remember, it has 7 valence electrons, 2 from the s block, 1, 2, and then we have 5 from the p block. So 1, 2, 3, 4, 5. So S2P5, S2P5, you can see exactly how those valence electrons support each other. And finally, for neon and E, these are your noble gases, which means they either have 2 or 8 valence electrons, which means their shells are completely full. This means you're going to have 2 dots on every single side, but it's still important that you're representing it properly and drawing in the proper order so that you get that practice to do that. So it goes 2 from your S block, 1, 2, and then you have 1, 2, 3, 4, 5, 6 from your P block. So it's S2P6, and you can see it here, S2P6. Now, if we're going to go through and do all the Lewis dots, all of these would have, in column 1, would have 1 dot to the right. All of these to represent your 1 valence electrons and your S1 shell, or your S shell with 1 electron, to be more specific. All of those in column 2 would have 1 dot to the right and 1 dot to the left to represent your 2 valence electrons in the S shell. When we're moving here, everything in column 13 would have 3 dots because it has 3 valence electrons, 1 to the right, 1 to the left in your S shell, and then 1 up in your P shell, and then it would go the same for all of these. So outside of helium, which is funny, everything in the S and P blocks, if you start at the top of the column and you can get that correct, and you can remember your orbits or your valence electrons, you can always copy it down because everything in these columns repeats itself. Thank you so much. Have a great day.